Assalamu alaikum everyone, and today we are going to be talking about the substitution nucleophilic or Sn2 reaction, and at the end of the video we're going to look at some other aspects of the Sn2 reaction. So let's get to it. For any nucleophilic substitution reaction, one atom or group is being replaced by another atom or group. Let's look at the Sn2 reaction. Now, before we learn the Sn2 reaction, first we have to identify three things. There's always going to be a nucleophile or a nucleophile, which is basically something with excess electron density. There's also going to be an electrophile, which is basically the opposite of nucleophile, meaning that it will have electron deficiency. And with every substitution reaction, there will always be a leaving group. Now, basically what this is that a carbon has limited amount of electrons. So if it wants to accept a bond, it can only do that if it then loses a bond, because then again, we only have a limited amount of electrons. Now let's look at this example over here. When the hydroxide attacks this carbon, the chlorine group must leave, which then gives methanol, and there's going to be a separate chloride ion. Now that we know what happens in an Sn2 reaction, let's look at the mechanism of the Sn2 reaction. Now, first thing to note is that whenever we're drawing any mechanism for any type of reaction, we always have to be careful about our electron pushing arrows. They depict electron flow and they have to be drawn in a very specific way, such as this one here. This oxygen atom has an ion. So that's why this arrow will start from here and then end at the carbon atom, because that's the one that's being attacked. And here the chlorine has to leave, so it's gonna go from the center of the bond to the chlorine atom, because when this carbon accepts this bond, the electrons will go along with the chlorine. That's how we get the chloride here. So we're always going to go from electron rich to electron poor. Now, with any reaction, there will always be a transition state. We can think of it as though like the middle of the reaction. Now let's look at some other aspects of the Sn2 reaction. One thing to note is that this carbon is sp3 hybridized with tetrahedral geometry. These are all 109.5 bond angles. And also for the Sn2 reaction, there's always going to have to be a backside attack. Meaning, well, for any reaction, the highest number of orbital of what is doing the attacking is going to dump the electrons on the lowest unoccupied molecular orbital, or what's acting as the electrophile. Because when this chlorine leaves, this carbon has one electron less. And then when these electrons make a bond, then the carbon stays the same. Now, whenever we're doing the Sn2 reaction, the molecule sort of inverts like an umbrella, as if the center is inverting here. So like we can see, the wedge bond is over here, now it's over there. Now the hydroxide is making a bond here instead of there. And then there's the transition state, which in every reaction there will be a transition state. We can think of it like the middle of the reaction. So basically this hydroxide is making a bond making a partial covalent bond with the carbon, which is acting as the electrophile, and the leaving group, which is the chlorine, is taking a few electrons and is also making a partial covalent bond with the carbon. Now these we can think of as half bonds, partially covalent bonds, but we can think of it as half bonds. And then these electrons get all taken by the chlorine, and the hydroxide is now the hydroxyl makes a bond with the carbon. And remember, this is all happening in one step. That's the key thing about the Sn2 reaction. Now it is a good question to ask. Why is it called Sn2 when these are all one step reactions? Well, it's because the 2 in Sn2 doesn't refer to the number of steps needed for the reaction. It's actually about the bimolecular transition state. Now, if you don't know what bimolecular transition state is, it means that the substrate is coordinated with the nucleophile and the leaving group simultaneously. So this is called a bimolecular transition. As you can see, it's making a partial covalent bond with the hydroxyl and partially covalent bond with the chlorine. So that's all there is to it. Thank you for watching. And if you want more videos about organic chemistry and math and science in general, then make sure to subscribe, leave a like down below, and comment if you have any sort of issues or problems, or if I made any error, or if you just are confused in one thing. Then please let me know down in the comment section. And thank you for watching, and I will see you next time. Bye.